Welcome to Reducing Dynamic Dispatch. In the previous video, we looked at how compiler optimization modes affect the performance of our code. In this video, we're going to take a look at dynamic dispatch. We'll discuss the performance implications behind this type of dynamism, and we'll introduce the final keyword, which can provide a drastic performance boost. As with many other programming languages, Swift allows classes to override methods and properties that are declared in its superclass. This means that the application has to determine at runtime which properties and methods are being referred to and then perform an indirect access call. This is dynamic dispatch. Dynamic dispatch is what allows Swift to be so flexible, but the trade-off for gaining this flexibility is runtime overhead for each indirect usage, and as you know, all of our classes, methods, and properties are labeled as indirect by default. Dynamic dispatch calls are achieved by using virtual lookup tables to locate methods and then perform indirect calls. This is not only inherently slower than performing a direct call, but it also prevents compiler optimizations, which make indirect calls even more expensive. However, we're able to trade our dynamism back in for performance by utilizing the access modifiers final and private. The final keyword invokes a restriction on the class, method, or property. It tells the compiler that the object marked with final cannot be overridden, and in turn allows for direct calls and compiler optimization. Let's see this in action. With our Game of Life application open, we'll navigate to the life.swift file and add the final keyword to our class definition. This marks the entire class, including all of the properties and methods, as final. Now let's navigate to our XC test suite and run our tests. Keep in mind, we're already using our faster filter method along with whole module optimization and the final keyword. Let's run our test and see how it performs. Now, our evolve method is running at just 3/1000ths of a second. This cuts our previous best performance in half. Let's see how this change has affected our game's performance by testing it in Time Profiler. Let's first remove the final keyword and get a baseline CPU speed for a frame of reference. Now, let's run our application and transfer our session over to Time Profiler. Once your simulator is loaded, run your game and see how it performs. This is already pretty good performance, but let's see how adding the final keyword to just our life.swift class enhances our performance. Once you've made your changes, run the application and again transfer your session to Time Profiler. Once our simulator is ready, we'll run our game. And we get a rather impressive performance boost of about 10 percentage points. I'm seeing CPU usage as low as 11%. Go ahead and test the final and private keywords on more of your classes, properties, and methods to see how low you can get your CPU. In this video, we looked at how limiting dynamic dispatch can greatly improve the performance of our code. I encourage you to try these techniques in your older applications to see how much faster you can make them run. In the next video, we're going to look at the relation between reference types and performance.